Good morning, ladies and gentlemen. Welcome to a video on golf ball packaging. Now I'm going to show you an example that's not exactly the same as the question I've asked you, but the skills that I use in the example I'm hoping you'll be able to transfer across to the problem that you've been asked. So you've been asked how to package 6 golf balls in a little 3x2 box initially. I'm going to show you how to do all the calculations involving, imagine just 3 golf balls in a row lined up. And imagining something is pretty difficult. So anytime a math question asks you to imagine it or visualize it, first thing I would do is just draw a rough sketch. So what we're expecting here is 3 golf balls, which are exactly the same size, in a box. And if we've drawn that perfectly, really, we don't need space here or here. We're going to assume that the box touches the end of the golf balls perfectly. Okay, so the question is, how big is this box? What are its dimensions? And to answer this, the information we've been given is we've been told that the diameter of each golf ball is 42 millimeters. Remembering, diameter is the entire way across. So each golf ball is 42 millimeters long, which means the length of our box is 3 lots of 42, which is 126 millimeters. Then, if you imagine looking at it from the end on, which would be like that in there, would have a golf ball there, and it would be 42 wide and 42 high. So really what we're considering is this square that goes all the way back housing our golf balls. Yours will look different, but the same process will help you. Draw out what 6 golf balls would be, imagine what each side would look like. But if our dimensions are, say, length times width times height, that would be 126 times a width of 42 times a height of 42. Yours will be different, but it gives you an idea. Right. Now let's imagine a net. For a net, I think a great thing we'd be drawing would be to work out what it looks like in 3 dimensions, and then imagine that cardboard box folded down flat, just like if you're going to break up your cereal box and fold it down flat. In 3 dimensions, and I'm terrible at 3-dimensional drawing, our box would look something like this. And within it are 3 golf balls touching each other. Alright, so the way I spoke to you guys about this in class, or a good way to visualize it, is imagine there is an angry little man standing in the middle of that box. There's a little guy in here. He's in the middle of the middle ball. And the first thing I would do is I would place the floor down, and that forms the base of your net. That floor highlighted in yellow is going to be the floor here. If you're doing it on paper and you have a ruler, fantastic, but do try and make it nice and neat. That there will have a width of 42 and a length of 126, all in millimeters. And it's important you include units in the net. Alright, so that's the angry man standing. Now let's say he pushes a wall down. Let's say this far wall here. If you imagine that far wall is on, well, if he's looking that way, it's on his left. So that's this one out here. I'm just going to draw that a little more to scale. Freehanding this is hard. Okay, it is also 42, because that 42 is how high the wall is here at 42. And it's 126 long. Then if we take, say, the other side in green, the other side in green, he's getting very coloured in, is this wall here, is another 42. And then the roof. The roof above him is a little difficult to visualise, but it's this up here that I'm colouring in multicoloured. That will have to fold out to one of the sides. It could fold out to here. Or the other side, it wouldn't matter. 42. Then, what's happening is there's a square at either end. So, one square here, that's this end here, and one square there. And each of those is 42 wide by 42 high, which is essentially that end section there. Alright, now we've got a net. Everything's in millimeters, every side labeled. If you want to be really fancy, and it helps you take shortcuts later, you can put a single dash through all the sides that are the same. So all the 126 is there, a single dash, and you can double dash every other side. Because really, there's just 2 measurements, which is pretty cool. Alright, so now, I'd like to calculate the surface area of this box. To calculate the surface area of the box, I want to see you think about the different lengths of the sides and how, well, let's consider the different shapes within the net. Really, each one of these is the same shape. 1, 1, 1, 1. If you wanted to, you could do 1, 2, 3, 4, and calculate the areas of 1, and then 2, and then 3, and then 4, and add them all together. But really, I want to do this multiplied by 4, because there's 4 lots of them. And then I want to do this shape on the end times 2. Your box won't look like this. Yours won't be a perfect square on the end. So you'll have to do this ever so slightly differently, but same sort of process, and I am looking for nice, clear working, either on the piece of paper you're doing it or on your screen. Alright, shape 1 is 42 times 126, and there are 4 of them. That 4 is this 4 here. Shape 2 is 42 times 42. Each of those, remember, is length times width. Length times width. And then times 2 on the end here, because that 2 lives there. And then we reach for our trusty calculators. 42 times 126 times 4 is a huge number. 21168. This one here, 42 times 42 times 2, 3528. Add them together, you get 24696 millimeters squared. And alright, volume. Sorry about that. To calculate the volume of my box, it's very good for me to look back at the original dimensions of it, the length, width, and height. Because for any rectangular solid, say a cube or a prism, a rectangular prism, the volume is equal to length times width times height. So for me, that is 126 times 42 times 42, and 126 times 42 times 42 is a very, very, very big number involving a lot of 2's. Millimeters cubed. Note my units. For surface area it's squared, volume it's cubed. Okay.